Hello everybody, my name is Sia and today I'm going to show you how to design Degenerate primers. So first we should select one gene which we are looking for example XRP2, SD1 or CXR4 or etc. what you want. So then we're gonna find homolog sequence from BLAST and we will take this process sequence and we will run multiple alignment and we can later pick up the primers. So I'm gonna show you how exactly do I am. So here goes. Today let's search XRP2. When you choose all database, it's going to be all. So you can choose gene exactly or directly protein, which I need to show you, but you can see later what it's gonna be. So search. Here we can see all data which belongs to this gene, and you can see here the tree as a list or tree, the taxonomy of the families or class which belongs to this amount of fish or any kind of bacteria or something. But today I'm gonna show you how I choose fish and align many fish species at the same time. Why I choose? Because I will work with this gene in fish species and I want to select conserve sequences from fish. Of course I can choose the other mammalian species or bird species and it show me how it's conserved between different class. But today I will choose more conserved in fish gene as XRP2. So I will click what I'm choosing. Degenerate is zebrafish, for example, and Posella reticulata it's copy. Let's choose one because here is two. We don't need the second one because it should be similar. And this should be tonga solea. It's kind of tonguefish, and it is damselfish. It's from chiclet family. This is kind of shark. Yes, it's shark, and this is Amazon molly. Probably yes. And here it's two different kind of isoform of this gene, and we can choose just one. And here it's Osantax mexicanus, it's Mexican tetra. Let's choose one isoform again, and Latimera it's Soleil count. So let's choose the first one. Okay, here display settings, and up here the same. So we can choose any, and first the sequence dot in text. Just click text faster and apply. Yeah, you see here everything by it's put it here, and we choose all and copy, and usually I copy in the text. Yeah, let's click this one. Text document, any kind of text document you can write, and hormonal sequence So paste. You can play with this name. Actually, when you combine a line, you will see this numbers, and actually if you don't remember the exact number it will be hard, but anytime you can choose it and you can delete, but doesn't matter. So let's close it. So here we're gonna use blast no block maker, which is a line, all sequence and faster format, and protein should be. It's exactly for Degenerate primers. So let's make, but first you can write here your email. Let's write, and here you can write any title. So write exactly to fish. So I said before, and let's make it. So make blogs usually takes very long time, and here you can see the result, but it's not ready yet. So let's go and wait. By the way, I will go check my email because I write in my email address. Okay, so here it's already came, and I can cut here. We don't need all, so we can finish here. So, okay, perfect. So next, CODEHOP website, it will help us to pick up primers. It's so easy, right? 128. It's a degeneracy level. When it's increased, the primer's quality will decrease. So we can choose lower, or we can see all of them, and then we can pick up the smaller degeneracy primers. So look for primers. So here we are, it's more fast, and here we see the old logs, which is name A, B, C, and it's going like this. So here you can see the first A part, it's almost beginning, and later it's more primers. We can see sometimes nothing, no suggested primers, and it's mean there is not a line sequences. So but mostly we can see here advised primers, and we can collect them. So actually it's done, but we need to collect and choose the best primers for us, and actually it's some kind of work. But now I want to show you how to select usually. For example, it's better to check out primers which we oh okay, so I will I will copy here blocks. So by this way we can see which blocks in which location. So for example, I want to make just this and this, yeah, sure, side by side. So here you can see, for example, B, block B is here. So let's check the numbers. It's 254, 348, and so on. And here the numbers is show us what is the percentage. But exactly one kind of another kind of website, which is Cluster, Omega, or W2, it's gonna show us the alignment result more detailed, and if it's like perfectly matched or half match or less than half, it will help you to choose exactly your place. But here also it's not bad. Let's choose B block because it's quite beginning, but it's not include some gaps, so it will be good options to check primers from here. So you will see it's kind of similarities, and we don't know exactly, but here the numbers is quite small. So let's pass to C, and here the similarities more than 80, and it's good. So let's start from C, and when you choose the primers as a forward and reverse, when you choose the from 3 primers to 5 primers, it gonna be forward, it gonna be reverse. So we would just choose as a forward, and reverse should be another block, include another block, and it will help us to find longer DNA fragment. So it depends how much you want long. So here, for example, I want 100 bus pair, no 1000 bus pair, and it's gonna be for example, if I choose in block C, here in block C it's around 300 and something, average should be 320 or something else. So let's choose from C as a forward, but here the Degenerate is 12, it's 48, it's 32, it's 16, 16 again, 32, 16, and here clamp needs extension, so don't choose this because you need to design extensions, and it's kind of problem next time, and you cannot deal with this easily. So I usually choose the lowest degeneracy average, and here is 12. So in this layer, the primer, which is match here from key to E, we can choose. So usually I copy all to not forget what I choose. So let's make a new file. Yes, and here primers. So don't forget to write which block is C. C as a forward. And we choose reverse primers. So let's see where I can choose. First we need to see to this. Okay, I want to show you how to choose reverse because it's important to define your target length of the sequence. Just later will be important because you will choose according to this information your markers and so on. So now let's find which blocks. It's C. So block C, we choose block C from beginning. This you can see R A R E A L E W A T E I and so on. So block C here, so it's the same, right? So we are here, so we can write approximately 300 or more. So let's write 329 as a location. Do not forget. So next, we don't know, but if you want final product size, if you want 1000 plus pair like me, you can choose 1329. So let's find where is it. 1300 something, so it should be around here. So here or up to you, it's not so big deal. So it's T and it's U. So let's check if there is any suggest primers for us. So I'm checking now. Let's go T. Yes, T. Oh, good. We are lucky, and here are some primers which is recommended for this fragment of protein. So let's check if it's correct. Yeah, it's correct, right? So yeah, it's totally correct. It's quite small and it's finished with I, and here is I. So, but you see the percentage of similarity between all species. If you write the name, which is what, in the first sequence text document, you can see which fish is which line belongs to which one, but now it doesn't matter to understand, but later you can do, or I can show you how to do with the other multiple alignment softwares. In that case it will be more useful. So now we can choose this just to remember how much actually it can be this also, because it's quite similar. So let's write here this one. Yes, the first one, because we choose the first as a location, so it will help us to calculate correct location. So it will be not 1000 1000 plus pair, but let's show you how much. 1288 minus 329, it's around 959. So it's nice, it's not big deal. So let's find reverse primer. Block T as a reverse. Write down like this because you can find and you can forget what you choose. So it can be forward one, reverse one, and forward one, because you can choose any primers here, and for each block you can choose all of them, and you can try which one is work well. So actually, when you get this data from CODEHOP, actually it's done, but it's a good way to collect primers and calculate and which primers that you select and send and choose and try it and so on. But now we're almost done, and I don't want to show you how to pick up all primers. Just let's pick up the primer, reverse primer from block T, and the reverse part it's gonna be 5. You see, here's 3 ending, and it should be 5 ending. So let's again check the degenerate. See, it's first one is 24, and it's quite high, and 32, and 16. So you see the lowest one is 16. So and usually this kind of beginning could be a problem, but it's better than the others, because here A, C, C, R, no, it's going to be like this, but it doesn't problem because the score is 79 and 76, sorry, and it's quite low when you compare the others, but it's okay. So let's choose this one, and you can choose any of them, but it's better to copy all of them, so to remember what you choose exactly, right? So that's all. Today we finish our work. You can collect the other primers from any blocks, and you can adjust your product size according to block location from this, from data of block makers. So good luck, and if you have any question, write me, and don't hesitate, send me an email. You can see my email in this video. So see you.